Hello, everybody. This is Mike Kay. I'm with Josiah Foster with Nationstar Mortgage. We want to share with you real quickly today in the 20 minutes that we have how Nationstar Mortgage went through a virtual desktop transformation, share with you what some of our challenges were when we were faced with the decisions that we had to make to go through that transformation, as well as the technical reasons and details behind what we did to make that transformation. I don't want to spend, I guess I'll give you my history. I am the lead engineer over desktop server and emerging technologies here at Nationstar. Josiah Foster is the senior engineer, and we will real quickly go through the history and what Nationstar does. I want us to spend the majority of our time on some of the technical pieces. So Nationstar is one of the largest and fastest growing mortgage servicing companies in the United States. At the time of the transformation, their portfolio was in excess of $400 billion, as well as 2.4 million customers. There was a significant amount of growth that the corporation took in 2013. That's sort of where this transformation started to come into play. The time that they spent growing from 2012 to 2013 was so immense in terms of the business that the infrastructure for IT and technology wasn't there, and that's what sort of forced the hand in making some of these decisions in this transformation. Our corporate headquarters is in Coppell, Texas, and we are publicly traded on the New York Stock Exchange if you want to check us out online. So real quickly, the challenges that I mentioned that we were faced with was with the rapid growth that the business had brought on in that year. In addition, they were really pressed hard to come up with a disaster recovery plan that they didn't have at the time. So in some of those challenges, we went from a 3,000 desktop workspace environment to about 8,000 users within about a year and a half time period, which definitely doubled, of course, the amount of capacity that we were going to need on the XenApp side. And we were faced with what are we going to do for an active disaster recovery goal, since we're in the position to have to kind of redesign this architecture, that we needed to keep that in mind. Of course, the big, most visible things that were seen by the business were the performance issues, as well as stability. Yes, from a back-end IT perspective, we needed to think about things like scalability, what we're going to do with the data center, and how we're going to provide some of that infrastructure. But the big visibility piece of the business was the performance and stability. It just wasn't there since they grew so fast and was still running on the same infrastructure. So in the environment itself, at the time, Nationstar was providing desktops and applications to end users almost through a manual process. Anytime that an expansion needed to be done to the environment, somebody literally was building out servers manually. You can imagine the challenge that takes in terms of just time, but how are you going to guarantee that what you're delivering is consistent and stable? How are you going to roll changes back if there's issues? Our applications weren't layered, meaning one application could be updated and we could affect multiple other applications which affected other lines of business. So that kind of went hand in hand with the fact we didn't really have a user topology or segmentation. Everybody was sort of bucketed into one type of user. So there wasn't a way to pigeonhole, okay, these people are servicing, these people are originations, these people are developers. None of that existed, so it made the environment challenges even greater in trying to determine how we were going to automate and scale to resolve the growth problem. As I mentioned, the business visibility was the performance, and because there was such a large number of users on what was a small design infrastructure-wise, there was a lot of freezing of sessions, high CPU usage, slow logins. You know, the things that end users are going to notice and scream about the most, of course. I think we'll get into some of the details a little bit later, but some of the logins at one point in time could take up to 4, even 5 minutes, depending on what was going on, to the point where end users would suspect something is wrong. We did have the lack of a profile management system, therefore we had a lot of profile corruption, almost a couple hundred a day, which really led to an impact to the business as well as perception as to what IT was delivering to them in this environment. So real quickly, I'd like to turn it over to Josiah Foster, and he can go over some of the details as to what we did in matching up with the challenges that I just outlined, some of the decisions that went behind that, and what the results are.
Yeah, thanks, Mike. Yeah, my name is Josiah Foster, and contact information there is that Twitter handle is @JosiahGFoster if you want to get in contact or maybe have additional questions that we are unable to get to today. As Mike mentioned, I'm Senior Virtualization Citrix Engineer with the Emerging Technologies group here. And as Mike kind of outlined the scenario as far as the really rapid and unprecedented growth for a mortgage company, and then some of the challenges with user performance, capacity, scalability. I'm really going to focus in on 3 areas that we addressed that are really part and parcel of any VDI environment. That's our broker, which is what we're doing with our Citrix technology, UEM, our user environment management, and also where we have implemented, really for the first time in our environment, truly software-defined storage to handle some of the performance and the IOPS considerations that you run into with any VDI deployment. So this is just a quick snapshot of what we had at the beginning of Q1 2013 in the midst of all of that growth. We were at XenApp 6.0, and Nationstar has approximately 10,000 employees, and about 90% of those are completely virtual workspace. So the majority are on XenApp hosted or shared desktops, and we have a smaller subset of power users and developers that do use Xen Desktop. At that time, as Mike alluded to, all of our server builds were completely static, so PVS was not in the picture. Our storage solution was a mix between Dell Compellent and the VMAX 40 from EMC. Hypervisor layers, VMware. At that point, we were at 5.1 since we have upgraded to 5.5. And from a profile perspective, we were just using traditional Microsoft roaming profiles. We were leveraging group policy a lot as far as the desktop experience. So we had a lot of GPO preferences for file shortcuts, drive mappings, printer creations, and it was one of the driving factors for each logon and reading through all those preferences that was really contributing to the extended logon time. And we did have quite a few stability and standardization issues as well. And because of that particular configuration, really kind of a legacy setup, we really weren't able to scale out and keep up with the growth of the business. So first of all, as concerning the Citrix technologies, one of the first things that we did is we did upgrade from XenApp 6.0 to 6.5, which I think most engineers would agree that it is, provides quite a bit in the way of stability and performance over 6.0. With some additional features and functionality as well. We did simplify to a single farm, and even prior to our migration to 6.5, we did do some stopgap things. We leveraged SCCM to standardize across the board on hot fixes and printer drivers, both Citrix hot fixes, Microsoft hot fixes. Probably the biggest change that we felt in the beginning of this transformation project was implementing provisioning services. We went live at the same time that we migrated to XenApp 6.5. We went initially with Citrix PVS 6.1, and since then we've upgraded to 7.1. But we realized immediately almost a 70% reduction in storage capacity. Our images that Mike was speaking of when we were rolling these servers out, it was pretty much all of the core applications that ran the business were in a single image, 2008 R2 server image that we were just deploying with VMware templates, and they were anywhere from 80 to 100 gigs. So you can imagine, just to build out 10 servers is going to require additional terabyte. So we did realize that storage savings immediately. We, since performance was such a factor for us to consider, and Citrix kind of had a negative connotation primarily because of performance, we did very ambitiously try and successfully use the PVS write cache to RAM option. with 6.1, and that was, we did see a great increase in performance at that point whenever the write cache was moved into memory. So at that point, with PVS, we're able to go to truly a non-persistent, stateless VDI environment. And of course, one of the greatest benefits of PVS is at that point, then our provisioning process was more than cut in half. Since we're streaming from a gold image at that point with 6.1, we positioned ourselves to quickly keep up with the growth of business. And also, it simplified disaster recovery. I mean, if with PVS, obviously with 6.1 and the advent of the versioning feature with PVS, it's just as simple as reverting back to previous images and then rebooting your servers. So the next piece, or the next area of technology that we greatly improved was our Uem solution, and for that we did move to the AppSense DesktopNow suite. The two products that we've primarily leveraged in the AppSense suite have been Environment Manager and Performance Manager. Well, first of all, with Performance Manager, some of the challenges that we had were certainly saturation, and some of the applications and some of the functions that our users were doing were really taking up quite a bit of RAM, so it was a premium for us. So we did leverage the memory trimming feature in AppSense, and essentially what that does is, as your users are using applications within their ICA session, if they have an application that's no longer in focus or it's minimized, the Performance Manager actually trims that memory down, basically giving you a greater availability of memory for system resources. Another piece of that was CPU clamping. So in any published or hosted shared desktop scenario, we sized ours to get about approximately anywhere from 18 to 25 users on these XenApp servers. But being in the financial sector, we have a lot of users who are heavy Microsoft Excel users, and occasionally they will run macros and queries that will essentially bring the server to its knees and spike CPU. So then the user experience for the rest of the users that share that have a session on that particular server is terrible. And so the CPU clamping piece with AppSense, essentially what it does is it monitors those rogue processes and will basically clamp them down a certain percentage based on how you configure it for a certain amount of time, so that it essentially allows the server room to breathe. So what we found in testing and then even after production implementation was that even when some of the queries or macros or processes from within user sessions were really spiking CPU, the user experience stayed fluid, and we no longer got those particular help desk calls about my session is freezing and it's completely locked up. The other product in AppSense that we have leveraged is Environment Manager. Environment Manager, I guess you could kind of call it GPO on steroids in some ways. We migrated pretty much all of our user GPO objects into Environment Manager, and one of the benefits that gives you is that GPO, when it runs during the logon process, is single-threaded, and AppSense is able to run 10 of those processes at a time. So you can imagine the increase in processing all of those actions during a logon. It also gave us the ability to use personalization, and why that is key is because with AppSense, with the EM product, we were able to completely eliminate roaming profiles and move to just a small mandatory profile for every user in the environment, and that mandatory profile is stored locally on our provisioning services VDIS. So that greatly improved our login time, and we no longer have those particular calls of profile corruption or profile bloat, because every user has the same small mandatory profile. And personalization allows you to do that because then you can personalize application settings that need to be retained that would have been retained in a roaming profile. The Environment Manager also gives us a lot of flexibility and really some creative ways in how we can manage our environment and deploy particular settings. It allows some process triggers that aren't available in GPO. So you're no longer just basically having to rely on, let's say, log in, log off, startup, or shutdown. But you can target session disconnect, session reconnect. You can, and we do a lot of process triggers. So if you have a particular application that needs settings whenever you launch it, we don't necessarily have to dump that all down at logon. We can wait till you launch that, and as soon as that particular application or EXE is launched, AppSense will then inject those settings either into your app data folder for your profile, or even into the registry if it's registry settings that are required. And it also allows us to do a lot of custom actions in order to, I would say, fix some poorly written applications. And we're able to do that with a lot of flexibility. So here's a quick snapshot of, by the end of 2013 and going into Q1 2014, we had seen quite a few performance gains. We went from sometimes 2-minute plus login times, depending on the load across the farm, to consistently 15 to 20-second logins. As mentioned, storage was reduced to about 70%. Moved truly to a stateless and non-persistent VDI environment. Probably one of the things that engineers love the most about PVS is that it gives you an absolute standard OS stamp across your environment, and it also provides for a great more deal of uniformity for the user experience as well. We had standardized on our storage platform to VMAX at that point in time. And then, of course, with our Uem Solution, which is AppSense, we did have consistent profile management. We're able to scale quicker. And then, if you look on the right there, it says 10 to 15 tickets as an average escalated to us, during the week or over a period of a few days. That is actually where it is. And to the left, where it says 200 to 600 tickets in the help queue, that is a reality of where it was at one point, just due to the absolute speed of the growth of the business and our attempt to catch up with infrastructure. But we still had some challenges, and so the last part of this presentation will kind of delve a little bit into how we met some of the challenges that remained, and specifically in the area of storage and software-defined storage. So with our decision to move the PVS write cache into RAM, and this is initially with version 6.1, it did come with some caveats. Even though we had sized properly the amount of memory that we needed for the write cache based on an entire week's worth of work on these servers, we estimated consistently that we could get through an entire week and just reboot once a week and we would be fine. There were some, a smaller subset of users that would do certain functions as they logged in across the farm that would bring it to its knees. And so, the challenge with putting write cache directly into RAM is that once it's exhausted, there's nowhere else for the operating system to write, and so you get the dreaded blue screen. And we would find that this could happen, 3 to 5 times per day. And it may not seem to be a lot when you consider the fact that there's 8,000 users and you have close to 400 to 500 XenApp servers. But with the user saturation around 20 users per VM, that could affect and was affecting upwards to 100 users per day. Their session would completely close out. And one of the other challenges we would have is that when the server did reboot, some of the applications didn't really appreciate the fact that there was a hard crash of the server, so files could be locked and sessions might have to be cleared on the application side and the back end. And so it did, contribute to some pain for the users and certainly some pain for us. We did upgrade to PVS 7.1, and we found that, and we did utilize the newest write cache methodology that was available to us in 7.1, and that was the write cache to RAM with failover to disk. And we did find this better. It did make some improvements, but it really didn't finally and completely solve this challenge for us. If you're familiar with this particular write cache option, essentially what it does is it uses the non-page kernel memory to put the write cache, or to locate the PVS write cache. And one of the benefits is that once you use that space and that user information or data is deleted, it will actually release it. And so you can last a bit longer on the amount of write cache that you put in memory that way. It's not completely used and locked as soon as data is written. And the other aspect of it is you have the ability to fill over to disk. This did give us a little bit of a buffer, but even then, once the write cache was exhausted, it gets into the disk space, I/O freezes, and even though it does a blue screen, it's essentially the same symptom, right? The session pretty much just locks up. And another challenge was utilization. So even after migrating our write cache into RAM and into RAM with failover to disk, because of that persistent disk that's associated with the PVS environment, still having the page file or the edge side engine, we found that we were still the highest consumer in our environment of IOPS in our production EMC storage frames. We accounted for approximately 70% of that. So with fast policy enabled, we would still be the largest consumer of Tier 1 and Tier 2, the SSD and fiber channel storage. And this again was due to the requirement for our page file being on disk, for edge side, and all those other things that are associated with the persistent disk in PVS. So that meant that, and that leads to the third challenge, which is scalability, which is that because we require that high utilization of IOPS still on our storage frames, that as we were trying to expand, that meant a lot of purchases would have to be made for additional shared storage. And it was especially a factor as a corporation have been moving to an active disaster recovery model, that the same amount of storage would be also required at our DR site. And so, the agility to quickly expand for rapid growth was impacted. And so that is where we engaged a company called Atlantis Computing, and we actually brought into our environment their product known as ILIO. It is completely a software-defined storage solution, so there's no hardware involved. And essentially what it does is it is a virtual appliance that sits in the hypervisor stack and converts your memory, your available memory on your blade servers, to RAM, and then presents that back to the hypervisor as an NFS data store. So you mount it exactly as you would an NFS data store. And so as far as the hypervisor is concerned, and as far as the guest VM OS is concerned, it's just another NFS data store. And so the question that you may have is, well, you're still basically in the same scenario. You've taken and you've placed it, it's still in memory, even though it's converted to an NFS data store. Well, there's some other functionality of the ILIO product that allowed us basically to regain that stability, and that's that it does inline deduplication and compression. So what we found is that with the inline deduplication, and essentially what that does is only unique data gets written down to the actual data store. So we reduced the amount of write cache space, if you will, that we needed, essentially almost by 75%. And the compression is a big piece of that as well. So even though it sounds a little bit counterintuitive, with the Atlantis product installed, your write cache option in PVS is just traditional write cache to device hard drive. But it also allowed us to completely alleviate our utilization challenges. And whenever you think of it this way, when we say we've put the write cache into this NFS data store, it's not just the PVS write cache. So it's anything that encompasses the persistent disk that's required for a PVS deployment, right? So now our page file's there, our write cache is there, logs, your edge side engine, everything now is completely running in memory in that NFS data store. And because of the deduplication and because of the compression, we're no longer running out of that space. And so we were able to completely offload 100% of our IOPS from our VMAX into memory. And so, that was a big win for us as a team to be able to, to go to the business and say, look, here's 100% of this storage utilization back, because at the time we did have quite a few projects that were in queue for expansion for applications, SQL servers, database servers, web servers that are now, able to utilize that space because we were able to return it to the business. And so that also helps us with the challenge of scalability, right? So now as we have built out our DR site, we were able to do so essentially just with servers and software. And it gives us a really linear and predictable growth model. So we have through our sizing exercises have determined what our saturation can be per blade. We know that, and we know what the costs are going to be per blade, what the cost is going to be for licensing. And since we don't require the additional shared storage at that point, we can just scale out with servers and software. It also does provide, some reduced network traffic related to XenApp because everything's essentially contained, within the chassis. We are primarily UCS customer using UCS blades for our XenApp environment. And so there was also a financial benefit to this too. Essentially, we were able to realize about 1.3 million in storage savings in 2014. That's the additional purchases that would have been necessary at DR and for other projects that we were able to give back, and also for other projects that were in queue, they're now able to use that space. And as we mentioned, it also gave us a predictable and linear upgrade cost. And I think our favorite aspect of that is that we were no longer racing to stop write cache exhaustion for users who were, blowing up these servers with poorly written SQL Management Studio queries or Microsoft Access. So if you are interested, and I know the presentation I believe will be at some point posted and available up in the CUGC. If you're interested in further information on any of these particular technologies that we have discussed, we did do some case studies with Citrix, AppSense, as well as with Atlantis, and our Synergy session I believe is still also up and available on YouTube. And in that particular session, we focused quite a bit on the Atlantis project as well. And with that, that is all that I have right now. I think we're just waiting on questions at this point.
Yeah, so this is George Abar again. And Theresa, do you want to take it from here with any questions we have? And just quickly, thanks Mike and Josiah for that presentation.
Yeah, thank you. It was really good. So there are a few questions, and we're still taking more if you're online and are interested in asking anything. So the first question is, how did you handle right-sizing your write cache and allocating your memory for the diskless solution?
Yeah, so initially, one of the things that can be done is to there's a couple of different methods. One, you can initially put your write cache to server and watch the growth of it over a particular amount of time. We had essentially already, since we had been live with PVS for a while, we knew what our general growth would be throughout the week. And so we did some at that point. We went with that particular number. Obviously you want a little bit of a buffer, but generally through observing your essentially your workload and kind of going from there.
Okay. So how much memory do you have running on your blade servers for the VDIs that you have set up?
Sure. Yeah, we're primarily we have the B230 blades primarily. We've been in a refresh project. We're going to the B200s. But when we went live, these blades had 512 gig of RAM, and essentially we found that if we allocated roughly 18 gig of RAM to each of these, to the ILIO data store for each of those VMs, then we had more than enough available for the system. In fact, even today, our bottleneck it's really not memory at all. It's primarily CPU. But yeah, those blades have 512 gig of RAM, and we usually do. We found our sweet spot to be about 6 XenApp servers per blade.
Awesome. And then we have one more. Again, if anyone has any more questions, please feel free to to send those in. So what were the specific challenges that you faced with the PVS write cache to RAM with failover to disk? Why didn't that work well for you?
Sure. Yeah, that's a good question. Essentially, it was really a use case that was a challenge, right? In a lot of environments, the PVS write cache to RAM with failover to disk may really be sufficient. But literally, our users and some of the things that they do with some of their queries, we would fail over to disk. I mean, well, I guess one of the challenges is once your PVS fails over to the disk, you are going to experience some performance degradation because the I/O split, depending on the performance of what you're using for the failover. But we did find essentially that even with that failover space, it gave us a little more time to try to, maybe log in and see what the user's doing and, try to kill a process. But it would actually fill up the available failover space as well. And so it was more like a kind of a temporary band-aid, but not a permanent solution, at least in our experience.
Okay. All right.
I guess
Theresa, there's a couple other questions. I don't know if you see them in the question box.
So there are some in there.
And Pat.
Yeah, I don't actually see those for some reason.
Okay. Well, the first one I can read. Can you see them? Josiah, Mike, can you see them?
Yes, we can see them.
Okay, well then go ahead. You just read them out so everybody can hear them, and then go ahead and answer them. Thank you.
Sure. It looks like one question is, did you completely resolve your BSOD with PVS write cache in memory with overflow to disk? The answer to that, and we kind of talked about a minute ago, is kind of yes and no, right? Is that when the write cache fails over, we found that once it hit that limit of what the available space on the disk, it did not blue screen, but because I/O was frozen, the session basically froze up, and we're still looking at having to reboot the server. I mean, it wasn't a hard crash, but it did still present challenges for us. So that's kind of why I mentioned in the presentation that it was partially successful. And again, I mean, in my estimation, it really depends on what your use case is and the behavior of your users. If you don't have users doing that type of work that's just absolutely draining all of your space like that, it may be completely sufficient for someone to use that option. And I think it is a certainly benefit over the previous just write cache to RAM option because of the way that it handles the write cache when it's in memory, because it's in that non-page area, that it's dynamic in the sense that it allows you to, as data is deleted, it will free up that space, which is unlike the RAM disk kind of option with PVS 6.1. And let's see.
So I can see the questions now. So that was Brandon's, correct?
That's right.
Okay. So the next question then is, when doing a PVS to memory with overflow to hard disk, why did you keep the page file? They say they personally turn off page files.
We did use paging, and this kind of goes back to our use of the AppSense Performance Manager with the memory trimming. Essentially, that's how it works. So we still utilize paging whenever it would trim that memory out. So it was a way for us to keep more available system RAM by keeping that page file there. But in other scenarios, it may not be necessary.
I think that would particularly be the case as well as if you're presenting a full desktop or a true Zen app published app. It may matter differently.
So Alan, someone named Alan is asking if this is where we post questions. So just a quick response to you, yes. So if you have any questions, go ahead and post them where you did that. I have a question while we're waiting for a few more. So you used some third-party options to come up with the right solution. Were there other products in those spaces that you had looked at prior to deciding on, like AppSense and Atlantis, for example?
Certainly there was. In fact, whenever we decided the approach we wanted to take on some of these ideas, we did do a POC with one or more vendors in each of those scenarios. We chose the vendor that fit our use case and environment the best.
Okay. I'm also wondering, did you, it looks like you maybe had spent quite a bit of time trying to get the product to work natively before moving in that direction. Is that reasonable assumption?
A couple of the phases, certainly. You know, we had seen great gains from some of the original changes we made, but we weren't 100% there yet.
So I still do not see, are there any more questions from the audience?
Tracy, do you see there's might be one from Jared?
No, I wonder why these aren't coming through right away for me. No, so if you want to go ahead and ask, that would be great.
Sure. So we have a question: how is Atlantis licensed?
Well, it depends on the product. I'd probably defer to Atlantis to give you all the details. I know with the ILIO product, it is, because the way that it works is that an appliance has to be installed, a virtual appliance has to be installed on each of your blades. So you're licensed per ESX blade at that point. But I do know that model, I believe, has changed in some of the newer products that they offer.
So do you run anything graphically intensive in your environment? And if so, how does that run on this platform for you?
We don't have very many graphically intensive applications today. Obviously, that would become another challenge for us since we are using the UCS blades. They don't have a graphics processor unit on them, so it would rely on software rendering. One option we do have, depending on the type of video we may render, is you can do things like flash redirection and to your endpoints, to your thin clients or your Windows clients.
Okay, so I don't know if I'm waiting to hear if there might be any more questions, or do you guys see any more questions since I seem to have a delay?
I think that's it. This will be last call for questions. Okay. And I think we're good. I'm going to go ahead and take the screen, and we will wrap up. So a couple things about this. I just want to say thanks to Josiah and Mike. They are both with the Dallas-Fort Worth CUGC and with Nationstar. And I want to say thanks to Theresa, who is with CUGC, and she is also a Citrix technology professional. You can follow up on mycugc.org. This will be posted as a recording, but there's also the user share page, some information about Nationstar's presentation here, and the CTPs have their own blog where there's similar content and discussion going on. And our last request is that if you have a similar story or some other story that you'd like to share with the community, email us at hq@mycugc.org, and we'd love to have other folks present and share their experiences with the community. And with that, I think that we can wrap up. So thank you very much, Josiah, Mike, Theresa, and thanks to everybody for signing on today's call. And please pass it on to other folks and let them know that this new resource is out there for Citrix users. Thank you.
Thank you.
All right. Bye, everybody.